Welcome. Thank you for coming here today to learn more about AI and how it's transforming higher education and also libraries. A big thank you to everyone who helped put on this event. It kind of spans our library, building services, staff in the dean's office, IT people, of course, our presenters. We really are very thankful that you're willing to do this. And of course, the principal organizer, Dr. Deborah Lee. I was very thrilled when she stepped up to take on a leading role in AI in the library and to integrate it with what's going on in campus. Her new role as Director of Research Impact and AI Strategy is something that's highly needed, and she's already made a great start at it. So I'm going to let Deborah talk a little bit about some of her vision and where she sees AI falling in the services that we offer. Thank you.
Well, thank you for coming today. It totally unplanned. We ended up with 2 events in the same week, and I think that speaks to across the campus. I think that speaks to the centrality of AI and how it's impacting our world. We're living in a time of rapid innovation where generative AI is transforming the way we think, learn, and work. This day is dedicated to exploring not only the opportunities these technologies present, but also the critical questions that they raise. As a university library, we are committed to supporting both the academic and professional growth of our community, and generative AI is increasingly becoming a key part of that mission. From reshaping the research landscape to revolutionizing how we engage with information, AI tools are already making an impact across disciplines. That's why today's discussions and workshops are so vital. We'll be hearing from experts on the role of AI in higher education and engaging in thoughtful dialogue about the ethical implications of these tools. Our keynote address is Dr. Jonathan Barlow, and after a break, our ethics panel will begin in the same room at 10:45. In the afternoon, we'll dive into some hands-on workshops to better understand popular AI tools, followed by a session on digital literacy, which is important but kind of hard to say, because navigating AI responsibly is a skill we all need to develop. These 2 sessions will both be held on the first floor in the 1405 presentation room. At 1:30, Dr. Megan Stubbs Richardson and Katerina Sergey, I may not be saying her name right, and I apologize, from the SSRC will discuss some useful AI tools. And then at 2:30, Lara Taylor and Mike Kentz will discuss the importance of building an AI literacy network or framework. Whether you're just beginning your journey with AI or you're already starting to incorporate it into your work, today is about learning, collaboration, and sharing insights. Thank you for being part of this important conversation. I encourage you to ask questions, engage with your peers, and take full advantage of the expertise we have here today. Together, we can shape the future of AI in education, ensuring it is used ethically and effectively. Enjoy the day, and thank you again for joining us. Now I'm going to do a very short introduction to someone who has really become almost synonymous with the discussion of AI across our campus. Dr. Jonathan Barlow is the Associate Director of the MSU Data Science Academic Institute and an Assistant Teaching Professor. Previously, Dr. Barlow was an Associate Director at InSpark, a research center at Mississippi State University. With a background in industry and university research, Dr. Barlow has more than 25 years of experience in software development, data modeling, data-intensive applications, and data analysis. Dr. Barlow received his PhD from St. Louis University, and his data science research interests involve natural language processing and the ethics of artificial intelligence. Please join me in welcoming Dr. Barlow.
Thank you so much. It's an honor to be here. I'm going to give him a second to get the PowerPoint working here. Beautiful room. I'm sure all the pictures will be great. I'm going to practice a little advancing the slides. Okay, perfect. Very good. Well, AI goes to college, learning and living with AI in research, teaching, and service. Just last week, we learned about the Nobel Prize in Physics. Quoting the Nobel Committee summary, quote, "This year's laureates used tools from physics to construct methods that help to lay the foundation for today's powerful machine learning. John Hopfield created a structure that can store and reconstruct information. Geoffrey Hinton invented a method that can independently discover properties in data, and which has become important for the large artificial neural networks that are now in use." Hopfield's approach, associative memory, constructed a network that minimizes energy in a way akin to minimizing loss based on error in the training of modern neural networks. The Nobel Committee produced these beautiful explanatory graphics, as you see, so definitely invite you to check those out. But it likens the network of trainable nodes, kind of like neurons, to a landscape in which each node's energy value could be thought of as a series of peaks and values that represent the training data, in this case, the letter J. Now, some, of course, are zealous for maintaining bright lines between disciplines and thought that this award given for basic insights that contributed to modern artificial intelligence was more of a Turing award than a physics award. So it's kind of fascinating to see at the very heart of Nobel right now is AI. Well, a few days later, maybe the day after, the Nobel Committee awarded the Nobel Prize in Chemistry to scientists who apply AI to protein folding prediction. And you may remember the person on the left, Demis Hassabis, from the documentary about AlphaGo, the system from DeepMind that defeated the world Go champion. So he's definitely a big player in AI still as well. Quoting the committee, "Chemists have long dreamed of fully understanding and mastering the chemical tools of life, proteins. This dream is now within reach. Demis Hassabis and John M. Jumper have successfully utilized artificial intelligence to predict the structure of almost all known proteins. David Baker has learned how to master life's building blocks and create entirely new proteins. The potential of their discoveries is enormous." And by enormous, they don't mean a horrible thing. They mean very large. So just to clarify that, that's a word. It's going out of fashion. The explanatory graphics are also very beautiful for this award as well. And you can see from the chemistry announcement, they had lots of pictures of synthetic proteins that can play roles like in vaccines, spike proteins, and that sort of thing, and also how AlphaFold works and uses AI to predict the folding of these amino acids and making of these proteins. And the other emphasis is that this model, the AlphaFold 2, uses the transformer, which is basically the same AI technique used in GPT to generate language. So very, very closely related to AI Day, Generative AI Day hit the library. Now, there's two implications of the 2024 Nobel Prizes. I think the implication of the Physics Award, it points to the inherent importance of AI as a scientific achievement. So it's very, right at the heart of science for the Physics Award to be given for AI and something basic like that. And then the Chemistry Award points to the importance of AI to current and future scientific achievements in every field. So the first one is for the inherent value of AI. The second one is for AI in every field. AI is becoming an important scientific tool or resource used in every field. Data science methods like AI that combine computing and mathematics and stats, informed by the theory and methods of every field, operate against field-specific data to promote discovery, invention, and improvement of human life. And a trend that you'll see going forward, and this is a couple of tweets, obviously the discussion of AI is happening very, very rapidly, and so Twitter is one of these places where you see a lot of it. You're going to see the use of science informing the way AI works. And so one example would be the first one there. This is a team that used AI to model simply just salt crystals, salt molecules. And what emerged from this are molecules that form crystals just like real salt molecules do. It's kind of amazing. And this is an emergent property of the network. It's not something that they trained it on. They didn't train it on crystallization. They just trained it on the properties of sodium chloride, but yet the crystallization resembled the real world. The second example is geometric constraints. And maybe they're trying to grow bone around a certain constrained part of the body. Maybe we're going to regrow a spinal part of the spinal column. And so we know there needs to be a hole in the middle for our spinal cord. And this is the kind of thing you can do as well. These systems can predict and be constrained and informed by something like geometry or bone structure. The third example is basically the same as the Nobel Prize for Chemistry, except for this is the AlphaFold 3. And AlphaFold 3 is when they announced it, of course, Google DeepMind announced it on Twitter. It uses diffusion models, just like the image generation code that created the picture of the person sending off their robot child to college in the title slide here. The same kind of technology is used to imagine what these proteins might look like on the way to validating whether they could exist in reality according to physical and chemical properties. So it's amazing to see AI being used in all of these fields and being constrained or informed by different sciences. So where are we now with generative AI? We've got Generative AI Day here. We've been living with GPT for a while, so it's nice. It's a nice time to ask about that. Currently, there are only a handful of so-called frontier or foundation models. OpenAI's ChatGPT is the most famous, but there's one from Anthropic called Claude. Google has one called Gemini. Elon Musk has one called Grok. And Meta Facebook models are called Llama, and these are the most prominent ones in the United States. There's a French model called Mistral that's very good as well. And there are models that have been developed in China. I don't have access to a lot of those, so I'm not as familiar with those as well. But these are worldwide projects. Even large companies like Microsoft and Apple have contracted with companies like OpenAI to incorporate these models into their products because these models are extremely costly to create and the knowledge to create them is very rare and it's not widely distributed. We also have a number of online services that are leveraging these foundation models to provide amazing tools. You can think of Perplexity, which is sort of like a search engine and a chatbot all in one. And they produce text, images, music, and even video is becoming better and better. Pretty soon you'll be able to, just tell a generative AI system that you'd like to see a movie in which two characters fall in love and there's a dinosaur involved. And I'm sure they could come up with a great plot that might be worthy of release. Ethan Mollick uses a great phrase. He calls this a jagged frontier because these models are excellent at some tasks and poor at others. Debates continue over how smart these models are, whether and to what extent AI will affect the labor market, the scarcity of training data and its ownership, how to manage the risk posed by AI, and of course, a coming wave of legislation, administrative regulations, and occupational best practices in just about every industry. So how smart are these models or how capable are they? Because many of these models only predict what a smart person would say. Some object to using the term smart or intelligent, but they're getting pretty capable, even if you don't want to use the word smart. For example, GPT-4, the version from 2023, scores in the 90th percentile on the Unified Bar exam, the 97th percentile on the SAT, and the 92nd percentile on the AP statistics exam. The newer models from 2024 are beginning to score even higher. And there's some newer models that are a little different than GPT-4 or 4.0 that approximate a more traditional approach to reasoning, moving beyond just a prediction of what a smart person might say to a prediction for how a smart person might talk through or think through an issue, and then train themselves on the right way to talk through or think through a question. This is GPT-01 preview, which is sort of the first preview we've had of a model that advertises itself as being able to reason about the world. To quote from OpenAI, in our tests, the next model update performs similarly to PhD students on challenging benchmark tasks in physics, chemistry, and biology. We also found that it excels in math and coding. In a qualifying exam for the International Mathematics Olympiad, GPT-4.0 correctly solved only 13% of problems. That's the best one that we've been using so far, while the reasoning model scored 83%. So quite a leap in capabilities from the normal text prediction models to the O1 preview, which actually does reasoning. So there's kind of a givenness to AI on campus. I mean, this is no one asked why are we having a generative AI day, just like no one asked why do we have internet access on campus. Eventually, it will be kind of funny to think back that we ever had conferences about AI, just like it'd be funny to think back that we ever had conferences about the internet, and we don't have those anymore because it's so ubiquitous. Then there is beginning to be a real givenness to AI, and it's not a crass matter of there's no going back or the cat's out of the bag. It's more like this: that AI is already part of our community. It's already essential to the work of many scientific disciplines and thus to the formation of future scientists. So there's really nothing, shady about that. I mean, this is something that's just a fact of life. Using AI and incorporating AI into products and solutions is also an expected workplace competency for our students as they go out into the workforce. AI is also an ingredient in good stewardship. Like any organization with challenges to meet, we have the responsibility to use methods that make the best use of resources, like time and money, to fulfill our mission of teaching, research, and service. And so AI is in our community. It's a given. This is the actual painting that inspired the painting on the title slide. This is Norman Rockwell's Breaking Home Ties, where you can see the young boy is going off to college. His father is sitting there on the I guess the tail of a truck, maybe, or they're by the maybe they're sitting on the running board of an older truck. Our university community has basically welcomed AI into our world. Now, our university is a community, of course. It has we pursue diverse subject matter. A lot of those subjects are starting to incorporate AI as an important tool. It contains diverse people, diverse ways of thinking and interests. We have many roles at the university: staff, administration, faculty, students. We have virtuosos of different sciences, and we have the apprentices that are learning to play the violin. To use the metaphor, learning to become virtuosos themselves. And then we also have stakeholders outside of the university that expect us to be on the cutting edge and to use these things wisely. There's also a givenness to our community. This is who we are. There's no way around that, just like there's no way around AI. At a particular geographic location and a historical moment, generative AI has made a dramatic entrance into our university community. So we just asked the question, are we ready? And of course, this is just one person's thinking through, are we ready? And hopefully we can get some input in the Q&A session. But are we ready? And let's use a series of questions to ask this. First, are we ready to enlarge our community to coexist with a new form of intelligence? Are we ready to educate students during the post-generative AI era and prepare them for life and work as humans in the AI era? Are we ready to lead in the two areas recognized by the Nobel Committee? That is, contributions directly to the science of AI itself and scholarship and research in every field that increasingly relies on AI for its next generation of progress. And then, are we ready to incorporate AI into our service to the larger community that relies on MSU as a public university and a land-grant institution? So first, are we ready to enlarge our community to coexist with a new form of intelligence? Some of the debates surrounding AI concern philosophical questions about whether AI truly reasons, has the ability to exhibit intellectual virtue, and some even discuss the hard problem of consciousness. We see generative AI as possessing some kind of opaque intellectual machinery, and while it produces amazing results and output, we're suspicious that there is some trick afoot. Yet what you're seeing here on this slide is still pretty much the state of the art for diagnosing one of the most significant human brain states that we face, pain. We ask those in pain to point to a series of increasingly despondent smiley faces because we assume it cannot measure or prove that the hurting individual is another being like ourselves who feels pain. Though we have a growing awareness of neurodiversity, that we don't all think the same or that there are multiple human intellects, it is still common to hear critiques of AI that employ a univocal standard for intelligence that includes humans but excludes AI. At the same time that we hold suspect the intellectual machinery of AI, as a public university, we officially operate within an uneasy anthropological consensus inherited from modernity, tempered by the organicism of the 19th century, and atomized by developments in genetics. As institutions, public universities have left behind classical, pre-Christian conceptions of humans in a great chain of being from purely spiritual to purely material. And we've also left behind the Christian consensus of the first medieval universities that placed humans in a community of thinking creatures like angels, squirrels, and frogs, yet distinguished by their bearing the imago Dei. Perhaps with Linnaeus in the 1750s, we were happy to classify ourselves as Homo sapiens, that animal with the ability to know ourselves, nosce te ipsum. We impose a test based on the capacity for self-reflection, the possession of which we can only prove to each other through speech or writing, output in the manner of the smiley face pain chart. Perhaps like Darwin in the 1850s and Haeckel in the 1870s, we think of humans in the context of all living things in a struggle for life, the most successful animals in history with faculties traceable to their utility for social and physical survival. And now, since the 1990s, we have deepened our experimental knowledge of this struggle for life and its biochemical mechanisms, and we have CRISPR and its promise to allow humans to take the reins of evolution and thus the future of human life and human intelligence. In short, the modern research university's current scientific approach to the nature of humanity adopts, at its most mystical, a view of human specialness that emerges somehow to be greater than the sum of the interactions of molecules, of physical stuff, of energy. Yet even as we mechanize and atomize the nature of humanity, there is an irrepressible instinct that this human collection of molecules is different from that rival collection of molecules over there inside of the AI, even though it produces speech, images that we may describe as art, video, etc. Even as the flow of scholarship and science tends toward removing a sense of the transcendent spark from humanity, we sense the presence of an intellectual, artistic, and even existential rival in AI. And depending upon how closely we have watched the science of AI unfold, we find ourselves and our students asking impolite teleological questions like, what are humans for? It's the new, why am I learning this? What are humans for? On Monday of this week, Tyler Cowen, the economist from George Mason University, tweeted this, quote, I've grown not to entirely trust people who are not at least slightly demoralized by some of the more recent AI achievements, unquote. Responding to the tweet, Ethan Mollick from Wharton Business School wrote, referring to his book, Co-Intelligence, Living and Working with AI, he wrote, in my book, I wrote that the cost of really getting to know how to use AI is 3 sleepless nights. If you haven't had at least a minor crisis, what does this mean for my job? What does this mean for my kids' jobs? What does it mean to think? You probably haven't used AI enough. This semester, our honors students, led by Dr. Clevenger, performed the classical play Trinumus and incorporated multiple robots into the cast. You can see the Pepper robot as a humanoid robot. You can see down there, there's a sort of a military robot that plays the role of an ox. The humanoid robot spoke, gestured, shoved, and was shoved by actors, other actors, human actors, and was cast appropriately as an imposter, a character, pretending to deliver a message from the head of the central household of the story who's away on a trip. Now, the paterfamilias was played by the student on the right, who is shown here in a scene where he discovers the deception against an AI-generated background that composed the entire set. From one perspective, this scene contains humans interacting with robots. From another perspective, there are 3 humanoid entities on the stage, each with intellectual machinery operating opaquely and only visible through motion and language. Perhaps in a medieval university, the theology and arts faculties would spot 2 creatures in the image of God and 1 creature in the image of humans, with angels, of course, just off stage, ensuring the safety of the actors. Perhaps Plato would see 2 humans and 1 of Hephaestus's automatons. In any case, the performing arts has shown leadership on campus by finding a way to incorporate AI into set design, the voice of the robot, the music used, and the robotics themselves into an artistic production. In the after-performance interview with the students, many of the students expressed the strong conviction that AI cannot create art. And as much as I respect the students' point of view on this, definitely, as an audience member, arguably, I was seeing humans create art alongside of AI, and it was a great experience. Artificial intelligence isn't human intelligence. AI agency isn't human agency. AI is a different species. But this doesn't solve every question we will encounter in the next few years, as AI leads our students to ask, what are humans for? And we must provide either an answer or a framework in which they can discover an answer. The givenness of AI, its facticity, won't allow us to credibly wave our hands and dismiss the real philosophical, anthropological work that needs to be done within every field. Perhaps in the same way that learning a foreign language makes our native language more familiar to us, it makes it a familiar stranger that we can know better, living and working with AI will make humanity a familiar stranger to us. Again, it will perhaps help us to refine our anthropology, our conception of what humans are as we stand on the cusp of modifying our own genetics and becoming a multi-planetary species. Current AI is a student of humanity. It is a product as much of physics and computer science as it is of the National Endowment for the Arts that for years funded the digitization of printed resources. All of the capabilities generative AI demonstrates derive from its assiduous attention to the digitized sum total of human, literary, journalistic, scientific, mathematical, programming, musical, artistic, religious, and social media output. AI is born not just of the great books, but all the books. It is a mirror that may help us to become reacquainted with ourselves as humans. In turn, our anxiety about a rival intelligence may be diminished, and we can learn to incorporate artificially intelligent entities into the university community. Okay, are we ready? Yes. Are we ready to educate ourselves during the are we ready to educate students during the post-generative AI era and provide them for life and work as humans in this AI era. Understanding and assessing our readiness to educate students requires some attention to the context in which AI operates, both as a subject of study, as a technology present in every field, and as a new industry sector itself. We first consider governance, the wedge up on the right there. AI rests on lots of data for which there are implications about ownership, privacy, and confidentiality. We're all concerned about the safety of AI in our lives. California's vetoed SB 1047 is an example of a recent attempt by state government trying and acting to set standards for safety and to regulate an industry that was born in many ways within its borders. But there have been national and international acts passed recently, including the EU's legislation on AI, not to mention private governance principles within companies and best practices within specific industries for using AI. In the university context, of course, we adhere to a principle of shared governance by faculty, and so we confront issues like the rise of AI by seeking consensus and working together for the good of students and the integrity of the academic disciplines. So far, MSU has used this principle of shared governance initially to draft suggestions for use of AI in the classroom and for academic integrity. In an ongoing way, the Provost's AI Committee, composed of academic and research faculty, seeks to find the appropriate way to incorporate AI thoughtfully throughout the curriculum. And events like the one today help provide a forum for considering the ethical dimensions of AI. And there's also an AI committee within the Office of Research and Economic Development at MSU. So MSU has really been ahead of the game on its approach to university governance in the age of AI. Infrastructure, the next wedge there, it's another key part of the AI context. The computation required for AI is immense, and this requires electrical power, water for cooling, storage for data, and fast and secure networking. AI's success rides on the success of information technology. In the classroom, this looks like fast and reliable wireless networking and student access to AI technologies required for instruction and preparation for the workforce. This may also consist of infrastructure to support instruction when we want AI to be absent and human interaction to be in the foreground. Ethics is another context. AI algorithms are beginning to be put in the chain of decision-making for financial, military, admissions, and other important aspects of our lives, and we want these algorithms to align with human values for fairness. In addition, ethics includes a culture of eschewing blanket negativity toward technology and positively embracing AI solutions when they appear healthy and useful to us. I won't say a lot about the ethics of AI, given that we're going to have a great panel in a moment about this topic, but it's a big part of the context. Strategic goals that operate within every organization and they're field specific, that's another big important part of the context. They form the important context for artificial intelligence and the way we'll choose to use it and not to use it. The industries for which our students will one day work each have specific interest in the success of AI. From farming to manufacturing, those interests are complementary, but perhaps a little different. Likewise, within higher education, we have strategic goals that shape how we will consider using AI, and we negotiate those together. Innovation is an important context for AI. Advances in AI itself, in the mathematics of prediction and description, in computer science and in data science are what has driven this unique moment in the history of technology. Research, and physics apparently too as well, from the Nobel Prize. Research initiated in universities and advanced in private industry is responsible for the almost magical technologies that are becoming just what computers do. We'll say more about innovation when we consider our readiness for AI and research. Finally, the people aspect is the most important part of the context for ensuring that humans benefit from AI. We must have people who, at a minimum, have AI literacy and who receive training appropriate for occupations at all levels within the economy and in all the supporting contexts, from data collection and the installation of smart systems all the way to AI developers and scientists who are responsible for innovation. This is the key responsibility of Mississippi's K-12 community college and four-year institutions to prepare a workforce capable of working and contributing to an AI-driven economy. This also includes upskilling and reskilling the incumbent workforce. With respect to AI and data science, this is often addressed by online programs at universities that target working adults. So now let's consider just a few of these contextual aspects in more detail to assess our readiness to educate. So it's not advancing. I don't know what to tell you. There's a really great slide next. You're going to be amazed. Okay, great. Can I try it now? If we got control. Oh yeah, it's working again. Great. Wonderful. First, let's consider the context of people. How are we doing in terms of degree programs that address AI? And I think we're really far beyond many other universities. In addition to the appropriate incorporation of generative AI into many aspects of the curriculum, our leadership has taken steps to address the need for data science and AI literate workforce by creating specific degree programs, certificates, and minors, including, and look at this, we have quite a few to boast about, BS in data science, a 2+2 for data science with community colleges is in the workings right now, a minor in data science, a BS in computer science with an AI concentration. That degree has been on the books for a decade, so that's a way ahead of the time there. A BS in artificial intelligence. I think we're one of just a few, maybe 2 or 3 universities in the whole country that have that degree, and that was launched this semester. An MS in data science, an online master of applied data science, really targeted toward working adults. And then a certificate in data science pedagogy, which is really aimed at assisting, especially community college instructors, in gaining the knowledge and skills they need to educate students in using AI and data science in the classroom. The Data Science Academic Institute website, shown at the left, attempts to promote and bring together student research in areas like AI, and the data science bachelor's degree is an inter-college degree that's proven to be an innovative formula for MSU's colleges to introduce degrees as concentrations that leverage the core data science curriculum with field-specific coursework in emerging fields like psychoinformatics from arts and sciences. We have social data analytics, which is a pretty unique concentration at Mississippi State, computational intelligence from engineering, sports analytics from kinesiology, and many other examples, including proposed concentrations that may put us first out of the gate in the SEC in areas like quantum computing. MSU is also partnering with community colleges, the K-12 system, and state economic development initiatives to ensure a unified state approach to technology, computer science, and data science education to address the needs of the AI era. Maine is one of the innovative joint initiatives, is a program that provides courses that faculty all across the state can take at all levels. And it's keeping all levels of education focused on AI in Mississippi. There was a representative from Maine yesterday at the research event. Next, let's consider the infrastructure for learning in the age of AI. This is another important part of the context. Let's take computing first. There are at least two categories of AI computing: training and inference. Training is computing that allows us to ingest data and create AI models. We could expand this beyond AI models simply to talk about computing used for analysis. The second, that's on the left here, and you can see that you take data and the output is a trained model. Inference is another type of computing. This is computing that allows us to make pre-trained models available to students and faculty so they can use the models interactively like they use GPT, and even write software that leverages inference computing to control devices, autonomous vehicles, or even just augment data as part of an analysis. For example, if you're analyzing social media data, perhaps leveraging through an API one of these models to do sentiment analysis and add a new column to your data set where it has the sentiment expressed as a number between 0 and 1 for every row of data. Currently, MSU has a variety of training compute. Most notably is Ptolemy, our 64 GPU cluster that is available for use by faculty, staff, and students. GPUs are important for AI computing. Basically, they're very good at the kind of mathematics and parallelization that's required for AI models. And currently this semester, several classes are using Ptolemy, the system, including the Data Science Institute's hands-on lab course in computing. In addition to the central resource, many departments have capable systems with one or multiple GPUs that are used for specialized research purposes. This type of computing differs from previous high-performance computing driven by pre-scheduled jobs applied to solving specific tasks, such as fluid dynamics calculations. Owning Ptolemy has given our HPC the chance to experience and learn to support the kind of interactive, iterative training work often done when working with AI. The system has, in a sense, made us smarter in an area where we are already a leader by introducing a new paradigm of computing. Mike Nowicki of the HPC and Carolina Siniskalki of the library received and have been working under a grant to help all of us learn to access and use this kind of computing on campus. With regard to inference computing, I'm not aware of any campus-wide resources at present. This kind of computing would expand the access to AI for our students, staff, and faculty from commercial sources like GPT or Microsoft Copilot, and enable the use of self-hosted, open-weight generative AI models that produce text, code, images, audio, etc., all without exposing any university or student data to vendors, even ones we trust. An example of this kind of inference computing made available to a university community is the University of Michigan's suite of 3 services. They provide to students on campus one called UMGPT, which is how they package open weight models for the university to use. So you go to this website and use it just like you'd use GPT, except for all the data stays within the university community and it's run on university servers. They have one called UMAZY, which is like a document repo for augmenting generative queries with internal documents. So you can add all of your PDFs to this repo. It probably uses a retrieval augmented generative approach, and it would allow you to then search your own documents. And then the UMGPT toolkit, which apparently empowers users to customize the use of the system to load new models and try things out on their own. So pretty impressive. Another example is the University of Florida's Navigator. They always put Gator in everything. So Navigator is their site. It makes many models available on campus, both self-hosted and all self-hosted at the University of Florida's massive computing infrastructure, HyperGator, or through Microsoft, Google, or Amazon cloud services. So they're also using the cloud and bringing them as well. That might be a good way for us to start because we can instantly spin up things in the cloud and we can have a trusted cloud provider if we like. What they've done is to take some portion of HyperGator's processing power and dedicate it to or share it with these inference uses by the University of Florida community. And you can see a lot of models are available there. Another kind of infrastructure perhaps needed for instruction and appropriate for the AI age may be spaces in which we fence off the influence of these non-human intelligences from our students as they learn to develop skills without training wheels. Some departments or colleges have purchased blue books for professors who prefer to returning to in-class essays and paper grading. There's also the increasing number of devices being put on the market, like the Free Write Alpha shown on the left, that have been developed to serve the needs of users who would like a distraction-free writing environment, but they still want to use a keyboard. Perhaps MSU in 2030 would be remarkable to us if we were to be magically transported, both in the large presence of AI and in the deliberate spaces in which we've carved out an AI-free zone, where we've decided that students need to be apart from AI for some pedagogical purpose. Currently, I don't know of any use of these devices on campus, but they do provide an advantage for students who have grown up typing and not writing cursive, and faculty who have grown accustomed to providing feedback within electronic documents. Additional activities would include our participation in efforts to create a unified curriculum within Mississippi in K-12 around AI and data science and artificial intelligence, because we really need to prepare students even before they come to the university. In K through 12, we really need students to be developing a growing AI and data science literacy, being aware of the important role of data in their lives and the important role of the processing of that data into AI models. In community colleges, developing expertise in applying AI in every industry. 4-year programs are building data science and AI experts and responding to the need for expertise in every college and department. And then graduate degrees, creating scientific leadership and advancing the fundamental science of AI in every discipline. This is really part of teaching students and making sure that at every level they are prepared. One activity of the Data Science Academic Institute is the attempt to map the occupations that exist in the AI workforce to ensure we even understand the workplace demand for AI knowledge and providing appropriate preparation for our students. Many jobs simply don't mention AI in the title, but are essential to the overall context in which AI is used in every industry. And understanding that need is going to be important for our curriculum changes or curriculum development. To understand where AI is in the rest of the curriculum at MSU, the AI committee is currently examining all the courses offered at MSU that relate to AI, mainly just to know what's out there. So far, we have found 48 that are directly related to AI, and I mean almost directly with the word AI in the title, to AI, and a myriad of other courses that incorporate some AI concepts or tools. So there's a lot to be proud of there in our curriculum. Finally, as we adapt to some of the ethical realities of AI, we will continue to mature in finding ways to ensure that students are learning, forming intellectual virtue, and receiving a credential that means something to employers, and is not just a sign that they use GPT to bluff their way through 4 years of school, right? Unfortunately, some of our methods of assessment were created in a world in which robots would be the ideal students. So that's the hard part, the finished essay. Hollis Robbins, I've used this slide before if you've seen it, but I do like what she says here. She emphasizes the role that experiential learning and internships will have in ensuring that students gain real skills and can demonstrate those skills to employers. She says, quote, "Education is still a matter of teaching people how to access information and how to turn information into knowledge. The written essay will no longer be the default for student assessment. Experiential learning will become the norm. Everyone will need an internship. Employers will want assurances that a new graduate can follow directions, complete, I didn't show your picture, sorry about that. That a new graduate can follow directions, complete tasks, and demonstrate judgment. And that's from her 17 notes on academic AI. Generative AI musters its an entire army for every intellectual engagement, but sometimes we just want to turn C-3PO off like Han Solo is doing here in this picture. Humans are selective. We're gloriously myopic. We're more affected by the recent things we've read than the previous things we've read, and we employ taste in our decision-making. Humans are more apt to ask, how would Vitruvius the architect approach this project, and not be troubled that they aren't also following the example of every other architect who's ever written a book about architecture. Recently, Dr. Snyder reminded me of Hugh of St. Victor's book on the arts curriculum, The Didascalion. Hugh helps us to find the bright side of our own selectivity relative to the intimidating amount of material consumed by generative AI models. So to quote from Hugh, who says that he's speaking for the educated, he says, "There are those who wish to read everything. Don't vie with them. Leave well enough alone. It is nothing to you whether you read all the books there are or not. The number of books is infinite. Don't pursue infinity. Where no end is in sight, there can be no rest. Where there is no rest, there is no peace. Do not be a hoarder, lest perhaps you always be in want." In the end, we're educating humans and must resist the AI ideal as the model for intellectual engagement. It's okay when you get back if you want to delete that folder full of PDFs that you intend to read eventually before you die. It's okay. Are we ready to lead in the science of AI and in the use of AI in every discipline? Are we leading in research about the science and theory of AI itself? Let's start there first, the science and theory of AI, the narrow domain maybe of the first Nobel Prize in physics, the one about the science of AI. These would be contributions to the theory of AI, not the application of AI, more akin to the physics prize. I'm not really in a position, personally, as just your speaker here, I'm not in a position to know our degree of contribution in this area because it's more of a matter of scholarship and publications, something that would require a formal study to see how we're doing in this area. But it would be interesting to discuss during Q&A if you are aware of, who are our Jeffrey Hintons and that sort of thing. So relevant questions for assessing this would be, I can give at least some categories. Are our scientists presenting at important AI conferences like NeurIPS? Are we publishing papers on basic AI theory and mathematics, maybe even ethics and safety? And who are our dedicated AI researchers, our Jan LeCuns and our Jeffrey Hintons? Who are these people that we need to know about, promote, and support their research? One of the challenges facing universities in doing basic AI research, especially in the area of generative AI, is the computing required. Access to computing infrastructure for AI research is extremely important. In 2016, when NVIDIA wanted to advance the science of AI, it donated its first AI supercomputer to the Stanford AI Lab, ran by the pioneer Fei-Fei Li. And you can see they're dropping it off. This is a tweet from 2016 where the CEO of NVIDIA is dropping off the computer, and they actually sign the top of the box. This year, Fei-Fei Li lamented that not a single university today in America can train the ChatGPT model, not even version 3. And this limits academia's ability, the public's ability, to support scholarship to understand AI, make a contribution to its healthy development, and develop a workforce capable of contributing to AI advances. For a benchmark, not too far over the state line in Memphis, Elon Musk's xAI just completed the creation of an AI computing center in the old Electrolux plant, no doubt, that consists of 100,000 of the latest GPUs. These will be used to train generative AI models. Each of these processors that they use, the H100, is estimated to cost between $30,000 and $40,000, meaning that the entire system was a $3 to $4 billion capital investment. This year, when NVIDIA wanted to donate its latest system to advance AI, they donated it to OpenAI, the creator of ChatGPT, and not to a university research lab as they did in 2016. But here's Jensen in 2024 to advance AI computing and humanity, and he gives it to OpenAI. MSU's cluster is actually on par with the cluster in Fei-Fei Li's lab at Stanford. We have 64 A100 GPUs. These are the state of the art right before the H100s came out, and it's completely on par with her lab. The University of Texas at Austin right now is creating a 600 GPU system, and it has H100s like the ones used in the old Electrolux plant in Memphis. To quote from them, open source models, open data sets, and interdisciplinary peer-reviewed research is the safest way to drive the upcoming AI revolution. Universities are uniquely suited to shape this ecosystem, And we are excited to be on the frontier of generative AI here in Austin. This is Alex Damakis. But if you think about this new 600 GPU system, that's still 0.6% the size of the cluster that XAI put into Memphis. So, it sounds amazing, and 600 is quite a lot, and we could do a lot with that. But that's pretty small compared to what industry has. Richard Feynman is famous for saying, "What I cannot create, I do not understand." Scholars and grad students in higher education need to be able to get their hands into the technology to understand it, advance it, and ensure its health. And incidentally, this applies to all parts of the ecosystem of AI. And that would be the people who support 100,000 GPU systems. How does that workplace skill get developed? How do you learn as an IT professional to manage 100,000 GPUs in a warehouse in Memphis? And that's something you have to learn in school as well. And so how do we do that if we don't have such equipment? Okay, that's research. Now, research into basics of AI. Now, what about the use of AI in every discipline, the application of AI? Are we leading in the use of AI in every discipline at Mississippi State? Many fields are making heavy use of AI at MSU for computer vision, for autonomy, for materials discovery, and natural language processing. We have clear strengths that we can leverage in high performance computing for every discipline. And we have seen the incorporation of AI into medical systems, chatbots, robots, and other engineering projects as well. I'm going to leave out some, no doubt about it. I don't know everything, so Q&A will be great to bring these out. Our research centers and labs are pursuing AI-focused research. We have a new Agricultural Autonomy Institute, which is about farm robotics, basically. CABS, which does off-road autonomy research and materials research. The Data Science Academic Institute looks at AI and chronic disease management for rural health, and AI ethics is a new area being pursued. The Social Science Research Institute, see some folks here from there. Very good. Social media analysis and using natural language processing, which is at the heart of AI. Closely related to AI is the use of digital twins that form the foundation for applying AI in architectural, physical, manufacturing, mechanical, and electrical systems. And I think we should take a moment to celebrate our own Dr. Nick Fitzke. He's actually a co-author on a paper with 2024 Nobel Prize winner David Baker, related closely to the protein folding research. So it's pretty amazing right here in the recent chemistry prize for applying AI to chemistry research. We also have additional research support available on campus. The library has dedicated faculty for data-intensive and AI aspects of research. Deborah Lee has been named the Director of Research, Impact, and AI Strategy. So we right there in the title, we have AI, which is wonderful. Carolina Siniscalchi is this assistant professor and was hired to be a data science coordinator to help people with data management plans. The archiving of the data that proves that we can reproduce the results that we get from large data sets that we subject to AI. Amazing. There's been seed funding available for getting research off the ground that applies AI in many areas. We have formal training sessions and conferences like this one. There's LinkedIn Learning now is available on campus. LinkedIn Learning has a lot of courses that relate to AI that you can take advantage of. And there's also Maine, I mentioned that earlier. Maine has courses that have been made available by Intel and Microsoft about AI. And then there's lots of informal know-how, colleagues sharing expertise and leveraging AI for research. There are a lot of people using AI. There are departments that have clusters of their own GPUs that are in buildings you wouldn't expect, and it's happening all over campus. And I think the University of Florida, if they bought a Roomba, they would advertise autonomous floor cleaning. And we're doing some amazingly substantial things, and we should really promote these folks that are doing great AI research. Are we ready to incorporate AI into our service to the larger community that relies on MSU as a public university as a land-grant institution? I won't say as much about service, but here we are essentially asking if we're ready to use AI efficiently to enhance our usefulness and our mission of service. And then I guess another way of putting that is AI increasing our productivity and our mission. Ours is in scare quotes due to a mismatch between individual productivity gains and the sense that we're not becoming more productive overall in organizations because of AI. There's some studies lately, 24% of American workers use generative AI at least once in the week prior to being surveyed, and nearly 1 in 9 use it every workday. And that's from August of 2024, so pretty recent results. Several scientific studies have shown increases in individual productivity, so they've given a battery of tasks to people. Some used AI, some did not. And there's a 25% increase on the tasks that have been studied so far, increase in efficiency. But anecdotally, when folks talk to managers, they do not see generative AI increasing the overall productivity of the team. And that's many think because there's a real difficulty in incorporating AI. How are we going to incorporate it into our existing processes? This requires research and development, and you really have to do it on campus in the organization where you're trying to apply AI to make solutions. And this has led also to discovering that there are many secret cyborgs. This is the term that's being used, secret cyborgs. These are people who are experiencing productivity gains and experimenting with AI, but are keeping their use of generative AI secret. So these are secret cyborgs. Ethan Mollick suggests a few common reasons why people don't share their AI experiments inside of organizations. First, they receive a scary talk about how improper AI use might be punished. Maybe the talk was so vague on what improper use was. Maybe they don't even want to ask. They don't want to be punished, so they hide their use. They are being treated as heroes at work for their sensitive email and rapid coding ability. They suspect that if they tell anyone it is AI, people will respect them less, so they hide their use. They know that companies see productivity gains as an opportunity for cost cutting. They suspect that they or their colleagues will be fired if the company realizes that AI does some of their job, so they hide their use. They suspect that if they reveal their AI use, even if they aren't punished, they won't be rewarded. They aren't going to give away what they know for free, so they hide their use. These are some motivations for the secret cyborgs. But the problem is that these secret cyborgs are the best source for finding out what works and identifying practices that we can make a regular part of our work across the board in an organization. I guess, Meryl, this is sort of like the shadow IT kind of use where people are using tools, and then a company discovers an amazing tool because some particular employee has been using it, even though they technically should not have been. So same thing with AI use. Next steps. So there's just a few suggestions based upon the questions we've asked so far about our readiness. And again, these are just my suggestions. We need to, as a community of shared governance, we'll figure out this together, but just a few things that naturally flow from what we've talked about. A few next steps are welcoming a new form of intelligence. To address this need to incorporate a new form of intelligence into our community, MSU should build a core of faculty to pursue the ethical, anthropological, and existential aspects of the rise of AI. This could build the capacity to pursue a National Endowment for the Arts Digital Humanities grant, or even to create a center on campus able to credibly engage the question that we're increasingly getting from students: what are humans for? To address AI instruction in our readiness there, we might be able to investigate the provision of inference compute to make self-hosted AI models available to students and faculty. This might be a very useful addition. And another thing would be to build the capacity to submit a grant for creating a distraction-free laboratory classroom without AI. We could even leverage this for basic research and have a classroom where students are using AI and students are not using AI, and we could publish in this area and really pioneer. We're really embracing AI when we know where it should be and where it should not be. So perhaps we could buy 30 of those distraction-free typing devices and outfit a lab with those. To address AI in research and scholarship, continue, of course, our productivity and applied AI research and scholarship, catalog and promote existing basic research in AI. Very often these grants are looking for, even the ones that are looking for applied research, maybe they're use inspired and would like for the use to sort of contribute to the basic research, or maybe they're directly aimed at increasing our capacity to work within the basic research of AI and the technologies involved, the mathematics, the science of AI itself. And so we need to catalog and promote those because we leverage those for all of the other projects. Do we have researchers who are limited by computing? We need to figure that out. That would be kind of like Fei Li's comment. And what do they need? What kind of computing do they need? What kind of resources do they need help with? What kind of knowledge do they need help with to use those resources? And then in what areas do we already have capacity for basic research in AI, and maybe expanding that? I don't know, maybe materials research would be a great applied one, but there's also, capacity for basic research. We do have we have faculty in statistics, for instance, who are focused on theory, and they would be perfect candidates for this kind of work. What about AI in service? A couple of ideas. Perhaps we should identify our secret cyborgs, bring them out of the shadows and popularize their workflows. Maybe that's something we could do. Also, discover any impediments to using the best AI tools. I mean, we're probably tying our own hands behind our backs very often because of our reticence to break any rules about data privacy. And so how can we eliminate those problems? Maybe making that inference compute available is one of those ways, but that might be a good way to begin to use AI more fruitfully in our service and increasing our productivity as a whole team. And that's the end of the thoughts I had. Love to ask any questions. Love to handle any questions. Thank you. Appreciate that. And I wouldn't want to say that our whole environment, maybe our assessments especially are that way, that really, okay, if you want me to be a robot, that's available now. I can do that. So, but if you look at someone learning to play the violin, they start out playing Mississippi Hot Dog over and over, and they get better and better in the presence of a virtuoso. And then eventually we can trust them with Mozart and all the other kind of things we entrust them with. So what does that process look like in the age of AI to become I don't know, maybe an apprentice to someone who's an expert and work alongside them? You see this in the sciences a lot. Laboratory science is a skill you have to gain, and you have to see someone deal with beakers that are dirty and clean them and weigh things and use the calibration for a scale and that sort of thing. So those are here too. So how do we identify those and bring people along in that mode of learning? It's hard, but it's good. Employers will trust us too.
Appreciate it. I hope. Thanks, John. This is really interesting. I hope this was recorded so more people can come. This should have been really well attended. If it is available, I plan on sharing it widely. This isn't a question, it's just more of a comment, because one of the first slides you had, I really liked that first part that reflected your background in philosophy and theology and so forth. You said at some point in the future, I don't know when you think that future will be, we'll laugh at ourselves today saying, what can we do with AI? Because AI will be inculcated into all of our practices in and out of academia. And I just remembered that I think it was 1991 or 2 or 3, my wife and I moved up to Cambridge, and we lived on the edge of Harvard and went to a lot of talks and so forth. And there was a conference on the role of the internet in society. They actually had 2 annual ones. I went to both of them, a few blocks from our house. Bill Gates was the speaker and so forth. But the discussion was about this internet thing. What do we do? It was before there was, browsers and all that kind of thing. It was really quite new. I was also reminded that in the late 1800s, many companies in America promoted a vice president of electrification. What are we going to do with this electricity? How do we leverage it? What is this all about? And so I wonder when you think, how long is it going to take before this kind of forum is moot and we just all use AI as naturally as all of us use a word processor today?
Yes. I mean, it's funny. The sociologists in the room probably would talk about the adoption and diffusion of technologies, and some of the disruption that's caused by that is how fast we adopt them. We didn't go from a 1 horse to 400 horsepower overnight. We have roads that are banked so that we can go around curves. We don't just have flat roads anymore. So we grew up alongside of these things. This is happening pretty quickly. I almost wonder how fast we're going to go from the incorporation of technology into some sort of interpersonal realm. Like, how are we going to deal with these things that are smarter than we are in some ways? How are we going to live with them? It's almost like we need psychologists and sociologists to come to the rescue here, because we're going to be interacting with these things in the way that we interact with other humans. They're going to be like pretty good humans and not like human. I'm not saying they're humans, but it'll be like interacting with a new digital species. And so I don't know. That's a great question. I do think maybe in the next 2 years we'll have these models will be so good that they will be just like effectively a grad student or better at your side, that you can trust more often than not. And like I said, they do amass all of their intellectual army at the border, at the point of greatest impact, right? They remember everything they've ever talked about. But you can ask them to think like a person that you respect. You can say, hey, how would Vitruvius approach the building of a building on Mississippi State's campus? And it would put itself in that mindset and try to give you some thoughts about that. So how are we going to do that? How do you deal with a person who is every person, all in one? How do we ask it to switch personalities? I mean, there's just 1,000 interesting psychological questions. Can we ask GPT to pretend to be a certain personality profile that we're really compatible with, according to the Big Five? And so that, see what I mean? So these are amazing. This is psychology almost. I don't know what that's going to look like, but it's a weird kind of technology to adopt, and it's a weird technology to see it diffuse so quickly and to be adopted so quickly.
Yeah, those of us that have had a close personal relationship with another human for decades, as I have, coming up on my 40th wedding anniversary next year, I just sort of imagine that your personalities adopt to fit each other, and that's what you know, remember the movie Her and some of these other movies, you kind of wonder whether the AI I interact with, whether it's Gemini or whatever, in 2 or 3 years, will be very different than the AI that you interact with,
Yes.
because it's going to adapt to our style of personality and our interaction and so forth. And that's what makes it really interesting to think about, because if I need it to be creative in a certain way that's different in the way that you need it to be creative, it works for me, but my AI may not work so well for you.
Yeah, maybe I'll file an HR complaint because Merrill's chatbot wrote me an impertinent email. But my chatbot is much more polite. You know,
I'm pretty sure emails I'm getting now already are drafted by AI, and I interact a lot with people around the world, and many of whom don't have English as a first language. And I've noticed how much better the writing is getting lately. So
that's great. It's a real advantage. It levels up. You know, everyone can be as smart as they really are. They can read as smart as they always have been, but the language barriers are starting to erase. It's amazing. It really is.
The conversations we're having about AI in 2024, while at the same time, we seem to be having this also concurrent anti-science movement in the popular culture. And nothing brought that out more than some of the things that came out about the hurricanes when they hit. So what is the role in the university in scientific literacy? And kind of helping the general population understand and see how they fit into this new world.
Wow, that's fascinating. You know, what do we do for pitchforks? You know, when the crowd with pitchforks comes, you know, I don't know. I'll just say this. I mean, I'm not a historian or anything like that. I mean, I guess a historian of ideas, but the I don't know. One of the things I've noticed with the increase in interest in blood and soil, nativism, those kind of things, those strike me as being very 19th century kind of feelings. And so we have examples of this, and you know, we know the rise of you know, movements around the world, culminating, of course, in some of the things in World War II. But how do you handle that? There seems to be a backlash against the technical. There seems to be a backlash against the impersonal. A turn from what modernism would tell us, which is that you know, it's more about what you choose to be, what you think ought to happen, what is the just thing to do, and toward what really happens. What are we really like? Do we really have affinities for people who are different than us? And if not, let's just stop trying to have affinity with people who are different from us. And so I don't know. It feels like a very I don't want to call it romanticism or organicism. I don't want to like tar any and feather any movement, but it does feel like that kind of nativism looks like a backlash against the high technology, a return to natural law instead of to kind of what we create. And modernism was all about creating a new world using new materials, glass and steel. We're going to make ourselves better living through science. And now there's kind of a backlash against that. So I think noticing these trends is helpful. I don't know, a kind of chastened modernism maybe that would address really true feelings that people have about these technologies, but also you know, sticking to the ideal that we can democratize technology, that we can all benefit from it. That's all I got, but hopefully that's helpful.
So one of the things I find particularly striking about this AI revolution is it's poised to make dramatic changes in the workforce. And us being a university, we're on the cutting edge of creating that new workforce. So I don't really particularly have a question or elaborate statement, but I'm wondering if you could speak on that topic.
Yeah, and I think that's the huge part about the people context of AI. And the other thing about the workforce, not only do we need people that have been educated in using AI and contributing to the science of it, but every job in an economy, like take electricity. I mean, what if we hired a worker in any context who had no idea what electricity was? So that would be any role in the economy that requires any level of preparation. They would run into trouble and dangers on the job. So the same thing with AI and data. Maybe data is really where you could start because you know, every company that competes against another company is managing data from, take a landscaping company. Think of all the data it requires just to get a team of people of the appropriate size to do a particular landscaping job with the appropriate equipment that's been maintained properly on a schedule, and where everyone's registering their hours, and there's a architectural plan that's been approved, and then there's levels of governance for all of these things. I mean, if they don't record the equipment that they use, they don't know how many hours the equipment has been operated, and they can't maintain it. So just maintenance is right there. They may not do the right job at the right spot. So just the commitment to making to having integrity in data collection and data quality, because we're going to train AI models on data. And if this data is wrong, we're going to reproduce technical bias. If the data has been if the data shows human bias, maybe in lending or insurance claims or something like that, we make an automated version of that. It's just going to reproduce those same biases. And so that's a very important thing, the data quality part. And if people at every level of the workforce or every level of preparation for the workforce are going to have to have an AI mindset, a data mindset when they approach the world. So, but I think Mississippi is aware of this. There are some states that started down the path of kind of a unified curriculum. We do this with computer science. We do have kind of a unified curriculum across the state, K through 12. Mississippi State's been a big part of that. But I think the AI and data education is part of it as well. So I don't know if that helps at all, but the manufacturers, they know what they need and they're telling us. And so our students need to go out there with this knowledge. I don't think it's going to fly to turn in anything that has grammatical mistakes anymore, because you could have just used GPT to improve it. So, why would our students ever submit anything with a mistake in it anymore from a grammatical point of view?
Yeah, John, you just mentioned the role of data, so that made me think of something. When I go to China, I see data captured everywhere. Everybody has a phone. Everybody uses their phone for everything, things we've never even thought about using our phone for. The former head of Google in China, who's no longer there because China's kicked out Google, says that data is the oil of the future. It's what drives everything. And the average Chinese person generates at least 9 times as much data per day or per week or per anything than the average American.
Wow.
And there are many more of them. So the amount of data that they have to create new AI models and advances and so forth is infinitely larger than ours. So he likens that to, he says that China is the Saudi Arabia of data. And I wonder how you can speak to the global competition, because we really have 3 internets now, don't we, with what the EU is doing to try to also limit the ability of the big American behemoths, the Microsofts and Meta and Google and so forth, and Amazon, and what they're doing and how they've been finding and limiting the monopolistic power of the American companies. So we're really kind of evolving toward 3 separate pools of data, lakes of data, and I wonder if you think that's a limiting factor, and project a little bit what that might be.
Well, that's interesting. I mean, there is all the AI companies have been talking about a shortage of data. They need more data to train these models. And most companies are sitting on a lot of gold, or oil, if you think of it like a resource. And so, being good stewards of our resources, it would be like having gold in the basement and not using it to improve your roof if you had a leak in the roof. And so there's a lot of value in that data. Mississippi State has been doing scientific agricultural work for a century or more, right? Century and a quarter, maybe. I forget the exact founding date, but think of all that data and what it means and what it could mean for agricultural research. Part of it is difficult to collect. It's hard to put into one place. It's hard to digitize in some cases for older data. That's when I mentioned the National Endowment for the Humanities, they did fund a lot of digitization projects. Google actually very early on scanned all the books in one or two of the college libraries. That's how we have Google Books. And that really started them down that path of analyzing, text data. But then there's video data that's collected all over the place. There's all the photos. I think a lot of that data is owned by someone. Perhaps in some countries, the privacy laws are quite different. We don't expect privacy in public in the United States. And so there's cameras on poles everywhere, and we all accept that that's okay. But like our own private data, that's really difficult to think about someone using or leveraging to train AI without our consent. The other whole part of data is the data that you create that you don't know about. Your cell phone, if you play Candy Crush, it's probably still telling that company where you are right now. And that company can turn around even selling de-identified versions of that data to other companies, defense contractors, tracking companies. And all they have to do is follow your dot, even if they don't know who you are. If they see that dot spend 8 hours at one address, sleeping one night, hope you get 8 hours, that'd be great. Let's say it's 10 hours at that address. You watch a little TV and then you went to sleep. They're going to look up the address there and then link your name with a potential person who really has that identity. So there's a mountain of data that we're creating that we don't know about. And of course, the privacy aspects of that are pretty alarming. But that data is very valuable. I mean, there's so much, we could learn so much about many topics if we're willing to use that data. And so we have to kind of overcome the ethical hurdles and making sure that people use it responsibly. But I think there's so much untapped data that I don't know how we get to it all. But it could be a strategic disadvantage, sure. I mean, if an enemy can make 40 decisions a second, and you can make one decision an hour, good decisions. They're going to beat you in any kind of competition, whether it's economic or military. So we have, it's part of United States, strategic future is to be good at AI, no doubt about it. And universities have always responded to the needs of national interests like Sputnik. And so now, what is our response to the need to have a good AI for the future? So, yes.
Along the lines of data governance. So Mississippi State is sitting on its own mountain of data. We're sitting in a building of a mountain of data. But back to ag autonomy or Raspet Flight Center, all the things that are there. Mississippi State's rolling out Copilot Enterprise, which is our own private version of using, ChatGPT. What are we doing because the things we don't know about the data that's generated out at Raspet, we don't necessarily want that exposed to the training model of the Great Wide World. So what are we doing from that perspective to protect that information?
Yeah, I think that's a good question. I mean, maybe I don't even need to answer it, but I think, the question speaks for itself. I do know that in the case of Copilot, there are, we use Microsoft as a vendor for our email. So we have a lot of data that we're giving Microsoft that can make them smarter. And it would all just depend upon whether the terms of service allow them to use the data for training AI. Could Microsoft use data on making airplanes better that they get from Raspberry Flight Lab that we dragged and dropped into a file share that's accessible to the Copilot? Maybe so. We definitely know that they could also make emails better and the duration of email just because we use their system for email. So I just don't know the extent to which Microsoft is able to use our data for training. Probably it's pretty airtight. I would guess that our IT folks have made a really good have a contract that puts in a secure enclave or something. But yeah, these are the kind of questions we have to ask. Now, obviously, Microsoft's a vendor. They're not the state of Mississippi. They're not the federal government. They're not just our private concerns locally. And so, the extent to which you trust them and the enforcement of a contract with them would be the extent to which you would trust that data stays local and is used for our benefit and not for someone else's. So I hope that helps a little bit. You host your own models, all that data stays local. Open weight models are not called open source because it's not really software at that point. You're just getting a bunch of numbers that form a big matrix of vectors that you can use to generate text. And then anything else you can store locally in your own storage. And that's pretty helpful. Although we probably use vendors for storage. I don't know. It's a weird world.
Is it on? I just wanted to join in with Meryl in saying thank you for today. And I wish more people were in this room because I think anyone who was in this room would have sparks and ideas flying about relevance to whatever their little field is. And I don't know if there's a way for you to go on tour across campus to especially the corners that are filled with naysayers and skeptics. Because there's a lot of researchers who are stuck in their silos and they don't see the relevance and they don't want to go there and they have moral objections, and you find a way to reframe it so that they can do their research in a way that redresses their concerns. And I hope there's more of you. Thank you.
This might take care of itself, like the givenness of AI, kind of like the givenness of the internet. I don't know. That's a fascinating question. All right. Well, thank you all so much. It was really a pleasure. I really enjoyed the Q&A. And if you know about, who is our Jan LeCun, who is our Jeffrey Hinton, who's working on the fundamental science of AI, I'd love for you to drop me an email. I'd love to meet these people, and so that we can make sure we popularize their work, because it's scholarly work. I wouldn't always see it. I wouldn't know whom to search for. I wouldn't know what kind of co-authors they have and that sort of thing. So, and maybe I could figure out a way to do that, but with a team or something like that. But it takes a lot of time to do that. So I'd love to just hear who's doing that fundamental research to advance the science of AI, the basic science of AI, and then also anybody that's applying AI, of course. Anything that I didn't mention, feel free to drop me an email. I'd love to be aware of that. I am on the AI committee, and some of the folks in the room are on the AI committee as well. And we love to make everyone doing AI at Mississippi State famous. That would be our goal. And so, and we want to be University of Florida with their magical Roombas and and all that. So, thank you so much.